Now let's talk about another part of chapter 5 in your book. So I want to just show you a few things, again using Lab 5.1 in your book, just so you can learn a few things about chapter 5 from this one program. As you see, I still have it typed in on my screen. The first thing I want to show you is what happens if you don't have this include statement right here. So I'm just commenting it out. So anytime you want to test something or just see what happens and you want to take that line of code out, just comment it out. Already I can scroll down and see I have an error message that has popped up, okay? And that's because I've commented that out. But let's say you don't see that, because looking at the screen right here, you can't see it. So I want you to see what happens. So I've saved it. Let me build it. Let me show you what happens is you're going to come down here and you're going to get failed. And if you look up just a little bit, it says set precision identifier not found. What that means is that C++ cannot recognize the use of set precision because you have not included this library of commands. And that library is the IOmanip library that has the stream manipulators in it. So set precision is a stream manipulator, meaning it manipulates what is displayed on the screen. So remember when we did this before, we build it and I want to make sure it's correct, and we started without debugging, and you enter cells of 1,000 and it's going to give you projected sales. So look right here at the projected sales. It's $1,200, right? It has 2 decimal points, and that looks very pretty, doesn't it? So let's see what happens when you change some of this. So before I do that, I want to add another carriage return on my screen just to space some things out for easier readability, okay? So now let's go back up here and let's say what happens here if I put a 4. So it had a 2 and I'm going to change it to a 4, and I'm going to show you what happens when I do that. So it's not going to be an error because you can do set precision with 4 decimals places, but I want you to see what that looks like on the screen. So see how I got out 4 decimal places here? So that shows you what set precision does. Whatever happens if I had set precision 0? And again, we just rebuild the solution, start without debugging. Again, we'll do the cells of 1,000. And notice no decimal points came out, not even a dot, none. All right, so that's why we want to have 2 here, okay, because that makes it pretty to the screen. Remember, the screen is always about user readability. So I've already noticed some of you as a programmer are in a hurry and you don't space things out and it's not easy to read. Okay, when you're a programmer and you have a client who's going to read your screen, it's of utmost importance that they understand the screen and that they can read it clearly. So take your time with your screens, what they look like. Now let's come down in here and let's comment out the fixed precision line, set fixed precision, okay? Let's just comment it out. What I tell you about that, all that means is you're not going to use that line in the code. In this case, it's not messing anything up because I'm just not using that one line. Let's do start without debugging. Again, we'll enter the $1,000 cells. We'll pick code 1. And see what gets here. If you don't enter anything, you're not getting a decimal out, are you? Well, let's see what happens. Let's just make sure that gives the same results as if we had cells of 1,000. And what happens if we choose number 2? 11. So we're getting no decimal points out. So it's very important that we put that back in here, okay? So just make sure that you have that in there. Here's another thing. Suppose that you're coding a program and you don't know if something's being calculated correctly. So let's break apart this calculation here, right? And let's come in here, right above here, and let's put calculate the what would we call that? Sales rate. Let's see what they called it. I don't know what to call it. The percentage, because that's really what you're getting out. So here's what I want to do is I want to break apart this calculation right here, and I want to have percentage equal sales times rate. Now, why am I going to want to do this? Well, maybe I want to check my calculation for some reason. So I'm going to have to come up here, and I'm going to have to add in like so. That'll declare it. And then what I might want to do is change this right here to percentage. And maybe I'm like, I just want to make sure I'm calculating that correctly. How can I do that? Because I'm just not sure. So what I can do is break it apart like this. Right? So let's see how that works. And that just breaks down my calculation, lets me be a little more secure in that it is working right. So I'm going to enter my $1,000, code 1. Now, I've got to go put it in return, but percentage is 200. So I know then I've got 1,000 plus 200 equals 1,200, and that would be correct. So, but because that ran together like that, let's fix that a minute. Right here. Remember, end line. Okay, and that kind of fixes that and lets me know that I am calculating that correctly. I'm going to show you one more time. Now see, I can look back and say, okay, that's right. It's just a little quick way to make sure you're doing it correctly. Now, the question becomes, do you leave that in because that wasn't on the specs, or do you take it out? So in this case, I don't mind when you show intermediate calculations as long as you're giving them the proper labels, okay? So in this case, you might leave it, or you could go change it back to the way it was, whichever you choose. I want you to, let's go over some of the questions that go with this. So it says, what rate will be assigned to the rate variable if the user enters 1, 3, 2, 4, and 5? So those are good questions, okay? So let's go back and start debugging. And I tell you what, let's do something even a little above that. Let's go back in here and let me add in something called display rate assigned. And this will show us also if we're getting the correct rate assigned. And again, I'm going to put end line on here just so it shows that better. So it's asking us a few questions. I got to rebuild, and then I'm going to start debugging. And so you could easily, by adding that line, oh, we have some errors. Let's go see what's wrong. Okay, why do we have an error? Cannot open. Okay, so every once in a while you get that because it's open. If you get this error, it's because it's sitting down here open from a previous run. So you just have to get it to go again. Here we go. Sales of 1,000, code 1, and the percentage for that is 0.2. Does that seem right according to the code? 1 or 3 is a 0.2. Yes, it is. Okay. Because I've added this in here, I'm going to come in here, right here. I'm going to do something, and again, this is for readability. Just adding that in. All right, so now we can see a little better. Sales of 1,000, code 1, percentage is 0.2. Why is it 0 coming out? Well, we didn't set precision before that, okay? So if we wanted it to display to 2 decimal points, we would have to come down here and basically copy this right here, statement, because what this does is works before the display, okay? So if I want to have it here, then my rate is going to come out 2 after. So let me show you that. Okay, here we go. So cells of 1,000, code 1. Now look, now I've got a nice pretty percentage. Everything's coming out decimaled correctly. All right, so we know that's right. And then it asks again. It says 1 and 3, so it wants us to enter 3. Oh, well, of course that's not going to be very high, is it? So let's go back. I entered the wrong sales amount. Sales amount of 1,000, code 3, it's at 0.2. Is that correct according to our code? Yes, 1 and 3 go together. Okay, but notice while the codes can only go to 4, there's nothing to prevent the user from entering a 5 because we don't have an error check on it. So what happens is 5 drops down through this if else right here, and it gets used the 0.15 rate because it says 1 or 3 gets 0.2, everything else gets a 0.5. So there's really no error checking on that, is there? Okay, why do we need this directive right here? And they have it labeled line 5. It's really what they mean by line 6 on my screen. It's just the way I've typed it. And again, that's the IO manip. It allows you to use set precision and get the decimal points out. Why are the literal constants on line 19, which is actually not that line? I'm going to show you which line it is. I'm going to look back at their code. It's down in the if statement right here. And it's the reason it's different is, again, I've added things to the program on the screen. Why are literal constants enclosed in single quotation marks? Because single quotation marks are what you use with characters or char, C-H-A-R. If it had been string, you would have used double quotes, okay, or double quotation marks. But because it's character or char, you have to use the single. Okay, how would you rewrite the if statement to use the not equal operator? Okay, so we have if the code is a 1 or a 3, right, and equal. So what if we want to use not equal, okay, without doing too much change? So suppose I want to say not equal. So not equal is the exclamation equal, not equal, and because I want to change this a little bit, I'm going to put 2 and 4 here. And I'm going to put not. Now there's going to have to be another change, but I want to start here. So suppose I have it's not a 2 and it's not a 4. What happens here, right? They get the 0.2. So let's see how that works. If I have switched that, I've got a failed. Why do I have, oh, I've got it open. Remember, sometimes you have it open below and you have to start again. Okay, here we go. Cells of 1,000. Now we enter a 1. What should we normally get? Oh, is that correct? Let's go back up here and look. So a 1 should be a 0.2. That is correct. Let's go back and see if it works for 0.3. I mean for if I enter a 3 code. So I enter 3 and I get it out correctly. And then let's make sure 2 goes correctly. Oh, that's good. We're going to have to do that one over because you know I entered that wrong from the beginning. So we still have cells of 1,000. And then we're a 2 code. All right, why did 2 get 0.2 when it should have gotten 0.15? Okay. It's because you have to switch the or to ands here, okay? So let's try it now. Again, remember you have to test everything. If you don't test everything, it won't work. Now I've gotten an error. That's because I have it open down below. I have to keep remembering to close it off completely. All right, let's do it again. Sales of 1,000. If it's a 1, it should be 0.2. All right, and we know 3 should be the same. 3, that got us a 0.2. Now let's try it. Sales of 1,000 and 2. Oh, good. So now I've got the 0.5. Let's see what happens if I do a 4 and a 0.5. Okay, so just know when you're playing around with the equal, the not equal, the ands and the ors, depending on how things are put together, can affect the if evaluation. So just keep that in mind as you're doing that. Let's see, it says, how else could you write this statement on line 26? I've already shown you a different way to do that. That's that calculation right here. And I've shown you how to break that apart. They ask how you might do that. And that's the basic questions for this. So it's a good learning tool is to look through the labs at the back and kind of work through the problems there to make sure you understand how they work. I hope this helps in explaining some of the concepts from Chapter 5.